Alright guys, I wanted to look at one question that looked at expected value and a fair game or gain. Alright, so this particular problem is a game of chance. There's a spinner. It's a normal spinner cut into quadrants, and so if we draw it over here on the side, it's just circular, cut into 4 pieces, 1, 2, 3, 4. Each one is exactly the same size. Now, depending on which number comes up, that's how much money you win. All right, so first, we're going to determine the expected return for one spin of the spinner. Now, we actually have 2 equations for the expected value. One of them is the one that we're most familiar with, is if we can find the expected value, which is equal to the number of times that we do something times its probability. Now, this one, that's not really helpful because we're only doing it once. So we're going to have to use another equation, which is this one right here. The expected value of our random discrete variable is equal to the average score. Okay, now the average score we can calculate by taking the sum of each of the individual pieces, how many numbers there are, and then multiplying it by the probability. All right, so what we're going to do is we're going to take each of these pieces, and so we're going to do the sum from 1 to 4, so 1, 2, 3, 4, and we're going to multiply the value of that times its probability. And so this is going to end up being, if I roll a 1, that's $1 times its probability, plus, now if I spin a 2, I get $2, and then we'll multiply it by its probability, plus, if I spin a 3, I get $5, and then if I spin a 4, then I get $8 times 1 over 4. And so this way we can find the expected gain of one spin. Or in other words, if I did a whole bunch of them, what would be the average score? Okay, so I'm going to have 1/4 plus 2/4, right? 1 over 4 plus 2 over 4 plus 5 over 4 plus 8 over 4. We end up getting 13, 14, 15, 16, 16 over 4, which then is $4. And so our expected gain for a specific spin is $4. Okay, that's the average. Now, that's for one spin. Sorry, the expected gain then depends on how much it costs us to spin, obviously. Right? Now, in this case, it says that it costs you $5 to play each game. So if it costs you $5 and you can expect a return of $4, then that means that the expected gain so this is the expected value, and then we're subtracting the cost, or what you have to pay, because you're going to have to pay that no matter what, then it results in negative $1. And so that is our expected gain. Now the final question is whether you would recommend playing this game. Well, probably not, because in the long run, you're going to be losing money. Now, in casinos, what they do is they get this expected gain to be really, really close to 0, right? Expected gain of -1, well, you know, people might go for that. They might not. You notice that only one of the 4 scores is going to get you money. Now, if you take the cost, and instead of making the cost $5, if you make it, say, $4.05, then you'll notice that 2 of the things will give you money and 2 of them will make you lose money. However, according to the expected gain, if it was $4.05, your expected gain would be -5 cents, which means each time somebody plays, the casino's gaining 5 cents. You get 1 million people to do that, that's a lot of money. So that's how it works in the casinos. They get something really close that looks like maybe it's a good deal for you, or maybe at least it's kind of close, and that's kind of how it works. All right, so I hope that was helpful, using the sum to find the expected value or the average. You'll probably see a couple more problems like this in the future. Ciao.